Okay, circles and completing the squares. So we'll talk about distance and midpoint. We'll talk about circles, the definition of the standard formula, and completing the squares. So we can know how to plot points. So -2, 1 is here. X is -2, y is 1. And 3, 2 is up here. So we can connect them with a line segment. And we want to know two things about this line segment. How long is it and what's the midpoint of it? So the midpoint is not too hard to find, right? It goes from -2 to 3 on the x-axis. What's halfway between there? Right, that's 5 units. 3 minus -2 equals 5. Halfway between would mean 2.5 units. So if we start at -2 and go 2.5 units, 0.5, that's our midpoint. X coordinate of the midpoint. Y coordinate goes from 1 to 2, right? Half of that length, 2 minus 1 is 1. So this is 1 unit long. Half of that is half a unit. So where's my midpoint there? It's going to be at 1.5. So the midpoint is, well, if I could draw it better, it would be about there. (0.5, 1.5). Right, so you can think about what's the x distance, cut that in half and figure out where that is. The easiest formula to do that is just say, well, I'm going to take 3 plus -2, which is actually 1, and then cut that in half, and that gives me 0.5. And to get this 1.5, I can take the y coordinates, 2 plus 1 over 2, and that gives me 3/2, and that's the midpoint. What's the distance? Well, this is a hypotenuse, and we can draw in the rest of the triangle. This distance is 5, this distance is 1. So if we call that A equals 5, B equals 1, this is C, we just crank out Pythagoras' theorem. A squared plus B squared equals C squared. So 5 squared plus 1 squared equals C squared. 26 equals C squared. Square root of 26 equals C. So the length of this is square root of 26. So where did I find A and B? This A equals 5. Well, that's 3 minus -2. So it's this x coordinate minus this x coordinate. Where did this 1 come from? That's 2 minus 1. Right? This coordinate minus this coordinate, and that gives you the length of the in the vertical direction. So the distance between 2 points, difference in the x coordinates squared plus difference in the y coordinates squared. This is Pythagoras' theorem. The midpoint is take the average of the x coordinates and the average of the y coordinates, and that gives you the midpoint. Okay, so circles. A circle is a collection of points, all of which are the same distance from a particular point. The distance is called the radius, and the particular point is called the center. So here's a circle with center at 1, 3. And the radius is 2, and that should be an R. Okay, so what's the formula for this circle? Well, if this is a point on the circle, we can call it x, y, because it's got an x coordinate, whatever that is, and a y coordinate, whatever that is. What do we know about this point x, y? The distance from the point x, y to the center is 2. So we can set up our distance formula. which is really Pythagoras' theorem, dressed up in his clothes, basically. x2 minus x1 squared plus y2 minus y1 squared. I put the square root sign in the last because I don't know how long it needs to be. That's our distance. But in this problem, our distance is going to be 2, right? Because we want points that are 2 units away from our center. And we want points that are 2 units away from this particular point. So we'll call x1 1 and y1 3. So that gives me x2 minus 1 squared plus y2 minus 3 squared inside a square root equals 2. Usually what we do, though, is we square both sides. We just write it like that. And we don't bother with the y2s because we actually want to leave these x2 and y2 to be the point x comma y that is on the circle. So it's just x minus y 1 squared plus y minus 3 squared equals 4. Great. So the equation for a circle just comes straight from the distance formula, which is just Pythagoras' theorem, right? This distance here is x minus 1 because this is the x coordinate, and that's has x coordinate 1. This distance here is y minus 3 because y is whatever height you're at. The center is at height 3. So x minus 1 squared plus y minus 3 squared equals 4 squared. It's just straight up Pythagoras' theorem. Okay. So that gives us a standard formula for a circle. If each k is this point at a center of a circle, and r is the radius, then this is the formula for a circle. So if we have this formula, what's the center? We have to be a little bit careful here because there's a sign. That's a minus sign here. So before we find the center, let's rewrite this. It's x minus minus 2 quantity squared plus y minus 0 quantity squared equals 7. So x minus something, y minus something. If it's just a y squared, it's y minus 0. But if we have an x plus something, that's x minus minus 2. So now we can write out what our center is. Minus 2 comma 0. So this is my h, and that's my k. The radius, keep in mind that this is always the radius squared. So the radius is actually r equals square root of 7. I have to take the square root of that, sorry. Okay, so sometimes circles have more complicated formulas, and we want to turn complicated formulas into the standard formula by completing the square. So this comes from the FOIL method of multiplication. So if I take x plus 3 squared, what is this? It's x plus 3 times x plus 3. What happens when I square something? When it's all the same numbers, I get an x squared for the first, I get 3x for the outer, but then I also get a 3x for the inner, and then a plus 9. The outer and the inner are actually the same thing, so we just add them together, and we get this. So because we added these together, the outer and the inner are the same thing, we got that 6. But that 6 was broken up. It came from the fact that there was 2 x plus 3s. And then the 9 comes from the 3 squareds. So if I see something that's x plus squared plus 6, right, that's the first part of foiling out x plus 3 quantity squared. And so we can start looking for a pattern. So x squared plus 6, x squared plus 6x. That's part of foiling things out. What would it have to be? Well, I know that 6 comes from 2 of these. So 6 divided by 2 is 3. And then when I FOIL this out, I have to square that to give us 9. So 6 over 2 equals 3, and then 3 squared equals 9. So if I see this here, that's a minus 10x. Minus 10 over 2 is minus 5. So that goes there. and then minus 5 squared is 25. So that must be there. So if I have an x squared plus 7x, and I want to say, well, that's part of foiling something out, but what is it? Well, we take 7 and we divide it by 2, and we get 7 over 2. I'm just going to leave that as a fraction. But what is this term here? If we actually FOIL out x plus 7/2 squared, the last term will be 49 over 4. So this term will be 49 over 4. We look at this, 8x, half of 8 is 4. 4 squared is 16. Half of minus 3 is minus 3/2. 3/2 squared is 9/4. And so if you know this number, cut it in half to get this number, and then square it to get that. Great, so here's an equation of a circle. What's the center and the radius? And can you put this into standard form? So x squared plus 4x right, is part of a FOIL. So I take this number and I cut it in half. That becomes 2. This number squared is 4. And you can check that. X plus 2 quantity squared is x squared plus 4x plus 4. Likewise, y squared minus 6y equals what? So there's a couple different ways to do this, to write this down. But what I'm going to do is to say that this minus 6x, half of that, minus 6y, half of that is minus 3. So I'm going to want a y minus 3 squared. And then my minus 3 squared equals 9. So I want a plus 9 there. So now I can relate my x squared plus 4x to a nice square and my y squared minus 6y to a nice square. So how can I use that to rewrite this equation, x squared plus 4x plus y squared minus 6y equals 12 as a circle in standard form? Well, if I add a 4 to both sides, that gives me my x squared plus 4x plus 4. If I add a 9 to both sides, that gives me the y squared minus 6y plus 9. But this I know is a perfect square. I can rewrite it like this. So that's x plus 2 quantity squared. And this, y minus 3 squared, that's all this here. And what do I have on the right side? 25 if you add it all up. Great. So what's the center of my circle? This is a plus, so the center will be at minus 2. This is a minus, so it'll be a 3. And the radius is the square root of this number. So my radius is 5. So completing the square allows us to turn parts of equations into perfect squares. So if you have x squared plus bx equals c, divide b by 2 and square it to get b over 2 squared is b squared over 4, and add that to both sides of the equation. So there's our b squared over 4 that's been added to both sides of the equation. And then this becomes x squared plus bx, x plus b over 2 equals c plus b squared over 4. And if you multiply this out, you'll get this. And so that gives us the process for finding the center and radius of a circle. If you have this, complete the square on the x's, then complete the square on the y's, you can turn it into standard form and find the center and the radius.